In this session, we want to look at method modifiers and formal parameters. So, as usual, my JLS grammar, my particular grammar that I'm interested in, and we have a compilation unit, normal, ordinary class we're creating, and let's see, I'll jump down here. We had a whole series of different types of expressions that we could see, that we need to go back and look at each of those, but I'm going to collapse those for the moment here and say that we got down to the point where we could actually put literal characters in here as our last terminal symbols. And I guess to review a little bit more, what we have so far is the keyword class, okay, followed by a name, an identifier for that class. I chose A1. Followed by a set of curly braces. And so the rest of this was enclosed in the curly braces that is the body of this class named A1 that we're defining. And within that body, we find that we have an identifier followed immediately by parentheses, preceded by a result type. And so, that's the clue that this is a method, okay, a method declaration. Okay. And furthermore, it was followed by a set of curly braces for the method body. So not only was it a method declaration, but it's also the definition of the method, of what the method should do. And all this method does right now is perform this one statement, okay, that is a method invocation. Okay. And so we looked last time that, there's something out there called system. There's a package out there called system. It has a class called out, and that class has a method member called println, and then we sent println an argument list, a list of arguments, actually a single argument in this case, that was a literal string of characters. Okay. So now what I want to do is come back and all the way back up here. When we looked at that method declaration, we found that the rule for a method declaration was a method header followed by a method body, but we could also have these method modifier things in there. Okay? We could have 0 or more method modifiers, and they would come before the method header. Okay? So, if we come back down here, then what I'm going to suggest this time is I'm going to add a method modifier before the method declaration. Okay? And a method modifier can be static or any one of these other keywords. Okay? So we'll want to eventually figure out what they all mean. Public, protected, private, abstract, final, blah, 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 as well as static. But for the moment, I'm just going to go with that keyword static here. And resist the urge to say that, that means that this static thing will be accessible without ever having an object of the class. That needs some examples down the road. Okay, so then I said, well, hey, since back up here, I could have, wherever my method modifiers go, there they are, I could have more of them. I could have one or more of them. I could have as many as I want. Well, not as many as I want, because there's only a certain set of possibilities. But I decided, hey, you know what? I'm going to include another one before all of this. Okay, so here's what I had. Static, my method declaration. And now I'm going to include another method modifier before it. And I'm going to use public as the terminal symbol for that method modifier. Again, I'll have to explain why that is, but it'll be better to see some examples down the road. What that means, though, now is that I have a class named A1, and it has a method named A4 that we're not concerned about the result, and it is also qualified as being a public method and a static method. Okay. Next, I want to go back and I want to also look at that formal parameter list thing. So remember when we created a method invocation, we had a formal parameter list here. Okay. After the identifier, inside of the parentheses, we could have a formal parameter list. And so here I am inside the parentheses for the method that I'm declaring named A4, and I'm saying I want to add a formal parameter list in there. So what could I put in there? What would it be? Well, a formal parameter list is one or more formal parameters. Okay? I know this gets a little bit lengthy. Let's see. Stretch that over there. Help a little bit. Get this up above here. And so the formal parameter list can be a comma-separated list of formal parameters. One or more of them, including the comma. Okay, so it's a comma-separated list of formal parameters. What would each one of those look like? Well, each one of them could follow the rule for an unannotated type followed by a variable declarator ID. Okay, annotations we'll deal with later. I feel like I mentioned this before, but annotations are a documentation kind of thing, not a code kind of thing. So basically we're saying we have unannotated types, which can make me think, oh, that means there's probably annotated types as well. Okay, but at any rate, we're going to satisfy that reference first, resolve that to some terminal symbols. So an unannotated type could be an unannotated reference type or an unannotated primitive type. We know the primitive types, char, int, byte, bool, float, those kind of things. But this time I'm going to say a reference type because I'm going to be referencing something that's out there in the API. Much like we did when we made the method, when we invoked a method, we had to have a method. Where's it going to come from? It came from the API. And so this time when I'm going to have a formal parameter, where's it going to come from? I'm going to use the API for that as well. So I want a reference type here. That unannotated reference type could be an unannotated array type. An unannotated array type, then, could be an unannotated class or interface type. Okay? And an unannotated class or interface type, I'm going to specifically choose the rule for an unannotated class type. Okay? I lost track of the fact when I have an unannotated class or interface type, that could be followed by a dims. Okay, so remember up here, this was an unannotated array type. Okay, so my array is going to have dimensions. We'll deal with arrays in more details later. But essentially, an array is a way to have one identifier with multiple values, and we can identify each individual value through a index. Okay, or what's referred to sometimes as a dimension. Okay, so I'm down here where I've said that I've replaced my unannotated array type with an unannotated class or array type followed by a dims. Okay, and so leftmost things first. So an unannotated class or interface type could be an unannotated class type. Carry the dims and the variable declarator down, like we have been. Let's see. There's dims. Why did I not highlight? There we go. Okay, there's dims, and of course, variable declarator ID has been coming along for the ride for a little while now. Okay. But our unannotated class type can be a type identifier. Comfort, because now we know type identifiers are identifiers for a type, but identifiers are chars or letters, so we get to pick something there. So a type identifier is an identifier, and I am going to choose string with an uppercase S. Why, you ask? Well, okay, back to the API over here. We said that we have these modules, and java.base is the basic fundamental module. Modules consist of packages. Inside the java.base module, we have the java.lang package. And the java.lang package is automatically available to us. We didn't have to do anything special when we went to the system class, but this time I'm going to look in the java.lang package and find that there is a, where to go, string. type. So there's a class for strings. And so what we find is, well, numbers and Booleans are native types. Strings are actually reference types. String, whenever we're using a string, we're invoking a class from the API. Okay. Anyway, so that's why I can put string here. And then dims can be replaced with square brackets. So whenever we have dimensions for an array, okay, and I said we can access any, first of all, an array is one identifier with many values. We can identify each individual value with this index, a number. Okay? And how does the compiler know if this number is an index into an array, or is it supposed to be an identifier or a numeric literal or something like that? And the answer is these square brackets. So remember, in documentation, square brackets mean optional. Okay? But in Java, in the code, square brackets mean, oh, this is an array index. Okay? And in this case, what we're saying is there is a string type that's an array, or we have an array of strings. So we're going to have one identifier here, and its value can be multiple strings. And we can access each string with a number. Okay, there's a first one, a second one, and a third one. Okay, so that takes care of the terminal symbols for my unannotated reference type here. And so now we can come back to variable declarator ID and see what we can do about that. We've actually seen this before, I think. A variable declarator ID is, and I should highlight, okay, let's come down through here, is an identifier. Oh, we get to pick an identifier now, whatever you want. This pains me a little bit, but I'm going to use args, because it is the standard conventional thing that people use, but we can see right here there is absolutely nothing magic about args. You could call that whatever you wanted. As long as you use that name consistently, you'll be fine. Okay, but I'm going to call it args. Okay, and so now we have this production here. Okay. And what I'm going to do is, remember, A4 was an identifier. Could have called it anything I wanted to, including calling it MAIN. Okay, it's just an identifier. Okay, so I'm going to change that to MAIN, and then I'm going to copy this, and I'm going to come over to my Java file here, paste it in there, save it, and then come over to my CLI and say, hey, Java C, what do you think about A1.java? The compiler's happy with it. I say, okay. Runtime, what do you think about A1? And lo and behold, it works now. We actually see something visible. I mean, it's been working all along. It's been compiling. That's critical. It compiled. Just because we didn't see any results doesn't mean it didn't do its thing. It was working, but now we can actually get some indication that it not only compiles fine, but it actually runs.